My name is Marcin Baryłka. This is Piotr Ćwiek. We are working for Samsung Research and Development Institute Poland. We are software engineers, so our presentation will focus on dev part of DevOps and strictly say dev for ops, because we love our ops and we want to make them happy. And we want to and we want to tell you about our adventure with remote task management using Saltstack. So, the story. We have lots of servers doing lots of things. We have servers doing, building data, binary data. We have servers transferring the data. We have servers doing the other things. All those things, all those servers could be grouped by their functionality. Administrators are unhappy because they have to configure new servers, administer them, doing things repeatedly. So we thought, why not automatize it, yes? I started the project, Piotr and the other colleague joined later. We started from the scratch, from the requirements. We want to monitor and manage servers, yes? Users should have access an administrator or watcher. Watcher is a simple user with almost no privileges to see server statistics only. The system should be easily accessible via the web. Adding machines to the app should be easy. And after all, we are R&D, not only development part, but research, and we wanted to do some research. It was the most important for us. What? Hey. Oh. Yes, działa. Saltstack was our answer because our beloved IT team used Saltstack before and told us, try it, it is cool, and it was. So, how Saltstack works? I have trouble with this. Oh, yes. So how Saltstack works? On the right side, you have minions. Minions is a better word than slave, isn't it? Saltstack uses minions. Unfortunately, we have to install an agent on Saltstack minions, but if you will do it, you will have control over all machines. On the left side, we have masters. Master. Have you seen Despicable Me movie? The animation? Yes, minions and masters, minions and Gru. Master sends orders to minions, configures them, communicates with them by 0MQ. So it's very fast. I've heard LinkedIn uses more than 10,000 servers and it lives.
I think they recommend around 9,000 minions per master.
9,000?
I think that's about the number.
Yeah, it's the number, yes. So this is very simple architecture. It works. Next slide. Okay, this is the basic. This is the basic comment when you want to run comments on minions. Sudo, everyone knows. Salt, this is the main comment. \***, it means run this code on all minions. Of course, you can specify here servers, specific servers, groups of servers, even operating systems, everything you want. cmd.run, it's basically run command from cmd package, means run this command on shell command on machines. apt-get install tree is Debian specific package manager. Wait a minute. Hi, hey. Hi. Okay, this is the output. As you can see, we have host 01, host 02. The output is specific for apt-get package manager, and you get it. Execution modules. Instead of running comments on shell comments on minions, you can run execution modules prepared by Saltstack engineers. In this case, user run install command from pkg package and install this package tree. Interesting fact is PKG package is system independent. So if you run this on Debian or Ubuntu, you will apt-get. If you run this on, I don't know, Red Hat, you will run yum. Saltmaster runs this command, transport it to the minions, and minions run this execution module. The output is YAML, so it's easy to read and easy to yes. Okay. Bloody. Okay. This is why we didn't want to get total access, total control to our users. You know, it hurts. Here you can find technologies we used. In our case, Ubuntu does not mean we don't know how to configure Debian, but we don't want to configure Debian because it's just an operating system for research. Python programming language, PostgreSQL database, Django web framework, Celery, Carbon, Whisper, Graphite, jQuery and Float to make perfect user interface, and Saltstack, of course. Okay. Monitoring. It's very simple, so I want to tell it quickly because it's very simple, and Peter Baumgartner of Lincoln Loop has made a very good presentation covering this subject. Here you can find it. It's a custom Saltstack module, collects statistics every 15 seconds, and saves them to the Graphite. It's kept for a year in minutely, hourly, daily, weekly, and yearly basis. That's all. That's very simple. Piotr will tell you about his work, very good work, about running tasks remotely on minions.
Hi.
This is Piotr.
Yeah, it's me. All right, so I'd like to ask how many of you have used Saltstack before? Some of you. So maybe it's not that useless that we explain those basic methods of working with Saltstack, and Marcin have showed you some basic execution modules, how the remote execution works in Saltstack. And Saltstack, of course, it's much more, but we concentrated on the remote execution. And I would like to continue with this a little bit to show you how you can write your own execution modules, because this played like a major part in our project. And to write an execution module, you use a very well-known programming language in turn. This time it's Python, so you write a simple Python source file. Let's call it mypkg. And this mypkg is important because this will be the name of the custom module. You throw there at least one Python function, let's call it myInstall. It can take any arguments you want, it can return anything you want, but what it returns should serialize to JSON, so be careful. And you also have access to this special salt variable, and it's important because it grants you access to anything that we've showed you before, all the standard execution modules. So in this case, as you can see, we're writing a simple wrapper around pkg install. So nothing new happens here, but in principle it could happen. And when we have that file, thanks, when we have that file, you need to place it either on the master host or better in a Git repository, which can be read by master server. And then you need to make those minions, the host that you want to manage, download your new module. And for that cause you use saltUtil execution module and sync modules function, just like any other execution module. And after that you should be able to use it just like any other standard execution module. So again, salt, the minions you're interested in, mypkg, myinstall tree, and it works. All right. Should I use it?
You can use it.
All right. So this is the diagram that you've already seen. On the right side is the Salt architecture with the Salt master server managing Salt minions. And what we added to this is this web frontend running Django and Celery and communicating via Salt API with master. Salt API lets you do remotely whatever you can type on the command line, just like we've shown you before. And the question is, why do we want this front end? The answer is we wanted to get rid of the command line. We didn't want users to have to learn Saltstack, type those commands, and not all of our users, our target users, were experienced system administrators. So they had a bunch of servers to administer, but they were interested in only very particular, specific, narrow things in them. So this web front-end, apart from getting rid of the command line, will also provide user management, permissions management, and servers management, task management, monitoring, and so on. We would be able to decide who is able to run what on which servers. Thanks. All right. So we have those custom execution modules, or maybe standard execution modules, and we want to run them via a web page. And we decided to wrap those execution modules into plugins so that the system can be easily extendable. We also plan to make our target users be able to write their own plugins and upload them. And our plugins consist of up to 4 files. 2 of them are required. One of them is a custom execution module, that's the blue one, and it lands on a minion. And the other one is a metadata file, and about the other 2 I will talk in a minute. So we already know how to write those custom execution modules. They are executed on minions and can do anything there, including RM, RF. So why do we want to write them? Because we could, in principle, use the standard modules. And we write them because we maybe want to enhance the built-in functionality. Maybe we want to combine a few standard modules together. We want to give like a common naming scheme for those files. And more importantly, the common interface. Because we want to pass JSON parameters into modules into certain format or any plugin configuration. And we want to return well-defined values. And I think this is the most important part because Saltstack modules generally don't have a well-defined return value. And we wanted to add, in particular, a status for every result, such as OK, warning, error, etc., so that it could be then used in notifications and monitoring of the servers. And apart from that, any additional data needed. Once we have the execution module, which does a useful thing, we want to make it visible in the front end so that the front end, the web page, is able to execute it. And for that cause, we use a metadata YAML file, which is required. And it normally contains some additional data for the plugin, such as human-friendly description, its status, whether it is enabled or not, its version, and any other configuration that the author desires to put there. All right, and now the 2 optional files. Plugins are configured, or the parameters are written as JSON, so they could be typed by the user simply as raw JSON, but we wanted to make it as user-friendly as possible for anyone. So we wanted to provide forms, well-defined forms, self-documenting, and so on, validating the input. And we used Django forms for that. So this additional file simply contains a special form for parameters. If you're familiar with Django, this will be very easy to you, and if you're not, it will be easy as well, because you simply declare what sort of parameters you want. Are these strings, integers? Is there only one? Are there many? Is it list? And so on, and which are valid. Maybe they need, for example, to be matched by some regular expression. Anyway, you don't care about HTML, CSS and stuff. We did it for you. And this is the example rendering of the previous form. And in this case, as you can see, we're choosing an action to do. Is it stop? Is it start? Is it restart? And we list services that we want to stop in this example. And of course, we have to select the minions. And then we click run. And then I'll tell you what happens. But for now, I'll tell you that all of this are simple, plain Django forms and form sets. So it's all on the web, documented very well. Very simple, no additional knowledge required. What we also provide, apart from automatic rendering of those forms, is serialization of form data into JSON. So this is the example JSON that results of the form shown previously. And this JSON is sent directly to the execution module so that it can know what to do and how. Then again, when the task or the plugin finishes its job, we want to see the results. And again, those results are JSON, as I said before. But normally, nobody likes reading JSON. So it's better to write a template, a Django template again, which is like somewhat like Jinja template, which produces a simple chunk of HTML to be embedded in a web page. And this results in something like this. We executed our task. We have a well-defined status. It's OK. And then any additional data that the plugin output from itself. In this case, it is a table of services, and thanks God, each one was successfully stopped. All right, so this will be scary, but bear with me. We defined the plugin, we created the execution module. This is the most important part and maybe the most difficult one. We also provided some additional UI-related files, a form and template. And now I'd like to explain you how we combine them together so that the actual work is done inside. And our architecture consists of 3 layers. One of them are Django views. These are Python functions that get requests from the web browser and answer with a web page. Pretty simple. Another layer are Celery routines. These are again plain Python functions, but they execute asynchronously. This is the main task of Celery framework, because we don't want the views to wait for the task to be executed, right? It can take a long time, potentially. Apart from that, routines in this layer will also update a database with the results of the task, and this database is accessible via those 2 layers. The third layer, which consists of Saltstack minions, execution modules and so on, does not have access to this common database here, although it could. If you know Saltstack, you also probably know about returners. So minions are in principle capable of writing to a remote common database, but we didn't want to do that because we would have to distribute login credentials to minions which we don't trust. Our assumptions were that we don't trust neither users nor servers nor anything apart from our own system. Okay, so in this scenario, the user has chosen a task, filled the parameters form correctly, selected servers, clicked run, and the view run task gets activated. And what it does is it asynchronously executes a helper function, run async, giving it servers, parameters, plugin data, and so on, and immediately redirects the user to the results page, although probably there are no results yet. And what this helper function does, it invokes via Salt API our custom execution module that we've written, giving it the parameters in JSON and other things. And it doesn't wait for the task to be terminated either, right? Because it can take a long time, so we don't want to hang on the connection. We just get the job ID back. This job ID will be used for future reference. because Saltmaster keeps a cache of the jobs being executed on the minions. So before returning this helper function, we'll again asynchronously invoke another one, lookup results, and this function is aware of the job ID, so it can inquire Saltmaster about how the things are going, how many of the minions have finished the job, how many not, and what are the results of those that did finish. And to achieve that, we use one of the Salt runners called jobs, and the function lookup JIT from that package, and we receive the results. So this routine receives results, updates the database, and before terminating, it executes itself asynchronously with a delay, and the thing repeats, and the delay increases, and the process repeats until all the results are ready, or a timeout expires. Okay, so while this happens, of which the user is obviously not aware of, the results page polls the common database with AJAX request to see how things are going, so the user is constantly notified about how many of its servers failed, how many of its servers executed the task, and so on. And if he or she wants to view the results of any particular task on any particular minion, he can or she can, and the template will be used.
Okay. I have to tell you we experienced some problems, unfortunately. First problem is our project specific. If the value returned by task can't be serialized to JSON, we don't get any response. So we are confused. We don't know what happens. So it's very important to prepare answer in JSON, even single non word. The second is salary specific. Salary plus more than one database equals data integrity loss. We had two Django's and one salary and two databases. And salary randomly to databases. Of course, we fixed it. Our op fixed it. We love him. But we lost a lot of time to fix it. And the third one is the coolest. We run Saltstack tasks so massively that we run out of inodes on disk. Because Saltmaster uses job cache and saves data on disk.
There's multiple files.
Yeah. We had to write a program who removes obsolete data. Now there is a possibility to make database cache, job cache. So in the latest version it is fixed. So you will not experience this problem. We did. And we lost also a lot of time on it. Any questions? Or we want to go for a lunch?
Yes, I get this question.
Because you talked mainly about master-slave configuration, I wanted to ask about masterless. Have you tried it?
Masterless?
Masterless configuration of Salt.
We haven't tried it.
No.
Okay.
We have one master and it works. Anything else?
Yeah, another question here.
Do you have any plans to make your web front end available?
Available?
Like open source?
Like open source, yeah.
That's a tough question.
Yeah.
I wouldn't bet on it, so.
It's not our choice, okay?
But we would love to, really. But
Okay, any more questions regarding the Saltstack and implementation in Samsung? Okay, I don't see any.
Okay, let's go for a lunch.
All right. We'll have one more presentation, one of the sponsor presentations, so please wait for another
Whoa.
2 minutes. Thank you so much, guys.
Thank you.